Now, indexing is a whole title on its own, really, and can become quite a nightmare. But what I'd like to do is introduce you to indexing and how you create indexes in Access and really why you would need them. Now, to create an index in Access is very easy. If we open the Customers table in Design View, we can see all of our fields and we can pick any one of those fields that we see fit to add an index to. And down here in the field properties, you can see indexed. And the options in the drop list are no, so not indexed, yes, and allow duplicates, or yes, and not allow duplicates. So any of our fields can be indexed. However, why would we want to index, and what does it do? Well, choosing to index a field, in fact, actually creates some more data in the database that you cannot see, the index data. Now, by default, what you'll find is your primary key is an index, and you can see here indexed, yes, no duplicates. So there's no duplicates in a primary key, but the column is indexed, and by indexing the primary key, we place our data in primary key order. Now, if we want to index another field, let's say, for example, the city, we can do that by choosing the field, coming down to indexed and changing to yes, with duplicates being okay because people can live in the same place. And when you click Save, we cannot change the sort order of the table because that's in primary key order. But what does happen is Access creates a separate index that will list all of our records, but simply two columns of those records. The first column that creates and shows the towns in alphabetical order, and the second column that shows the primary key. Now I can demonstrate that by creating a query that just looks at those two fields, which is the city and the primary key, and then sort them by city. Unfortunately, I've got the customer table open in Design View. Let's go back to the query and View. So this is what my index would look like. It lists all the cities that are used, and there's repetition because the cities are used more than once. And in the next column, we have the ID of the person. Now, the idea here is if we were to look for people that lived in Ballard, the database would find it easier to first come to the index table, which is this one, find all the Ballards that are in alphabetical order. So as soon as it finds the first one, we can keep looking until it finds the last one and then not look any further. So it would find the first, then find the last, and not proceed any further down that index table because it knows that index table is in alphabetical order, that it's got to the end. Then all it needs to do is hop across a little row, find the ID, and take the ID back to the customers table, find it down the indexed column, so the ID column here, very quickly because they're in order, and retrieve the rest of that data. So the whole point in indexing is that it speeds up retrieval of your data. Now, you would only index fields that you're likely to search on or group on or link to other tables or other sets of data. So you wouldn't index every field, although it would seem like a good idea because the retrieval of the data is massively speeded up when you index. The only problem is it slows down the data input. So every time you enter a new record into the customers table, a new entry must be made into the indexes that you've created. So this index here, which is our city index, if we entered a new record for Ballard, then a new record would need to be inserted in the right place in the index for Ballard, so that when retrieving people who live in Ballard, we are speeded up. So looking back at the customers table in Design, although we do have the query open, but we can say yes for read only, I would need to decide which of these fields I'm likely to be sorting by or searching by or grouping by, and then index those. Do not index every field. That will seriously slow down the data input, whereas the retrieval would be massively increased. So I've gone for city because that's likely to be a field I use a lot. Birth date, that's likely to be a field I use a lot. So I'm going to index those. And that will create me an index of all the birth dates in chronological order with the primary key next to them. That way it can find a list of birth dates really very quickly. So if I do a save here, which I can't because I'm read only, let's go back to View and create another new query. And this time we're looking at the birth date. and the CID, and the birth date is in ascending order. If we wanted to do a search for anybody born between two dates, then using the index is so much faster for access because it will come down the list chronologically until it found the first date, possibly potentially there, then carry on looking until it found the last date, and again look no further. So it's not having to go through all 18,508 records. It's only having to find the first, keep searching until it finds the last, then stop looking, and then jump into the second column and look up all of these IDs in the main table. But again, they're in chronological order, in alphabetical order, they're in numerical order. So it finds looking up the ID very, very fast indeed. So indexing is useful. The more records you have, the more you will notice the retrieval of the data is faster if you use the correct indexes for the data that you're searching on. Too many indexes, however, will slow down the data input, as each entry into the main table will also cause an entry into each of the index tables. Now, you don't need to go into the design of the table and go to each of the fields separately to create your indexes. If I close these two queries, I can go into the design, but then there's an indexes option up here on the Table Tools Design context ribbon. When I choose that, it opens a dialog box, and you can see in here we actually do have a number of indexes defined. The middle column here tells you the field name. The left-hand column is the index name, and in most cases that's just the name of the field. And then sort ascending, because you can make your indexes sort descending. Potentially, if you're doing a lot of data work on time and you're looking at the more recent stuff more often, then you would sort, for example, the birth date in descending order. So the newest people, the youngest people will be at the top if they're the ones that you're looking for more frequently. So you can actually add your indexes using this little dialog box. It's not just to view them. We simply click in to the field name option and choose the field name we would like to sort by. We may do that on marital status, for example. Notice the default goes to sort order ascending, and the index name is left blank, but we can call it whatever we want. It's logical to call it the name of the field, because then you can see what's going on. In the options below, we have the option there to change that to primary, which we can't really, because we already have a primary key. Unique, so the default is no. So the marital status is not unique. They can repeat. Well, it does need to be able to repeat. Lots of people are married, lots of people are single. And we want the indexing to ignore nulls. Now, the default here is no, but we could change that to yes, and then empty fields are not indexed. So there will be no entry in the index table for a null value in the marital status. So this is just another way of adding in your indexes other than going to the actual field in the table design and coming down to indexed in the bottom. Hopefully that's been a good introductory to indexes, because they can get much more complicated, but they are extremely useful when extracting and querying data in a database.